This is the RunSafe Security Minute. We're here to provide 1-minute security briefs. Today's question is,
Shane, show us how to deploy RunSafe code in a build system and show us how RunSafe protected software prevents exploiting a vulnerability.
Yeah, thanks, Alex. So what I'm going to show here is two different Docker files here. The one on the left is one where we're just going to build some software normally, and on the right, we're going to show building it with the RunSafe code protections. And we're not going to actually do those builds here. We've got the images already built for that. But at the top, we just want to show you what the difference looks like. So, we're running in a normal CentOS 7 environment over here. We're installing, compiler, GCC, make, some Python tools, and some other things that may be needed for a build environment. And we're actually running make to build the software, as you can see down here. And then we're going to run make install. And so when that software builds, it's going to basically have a GPS logger that might be used in, automotive or aerospace or, somewhere else. It's just kind of a representative program. But it does have a buffer overflow in it and an information leak that can be used by attackers to exploit that logging capability. And so we'll show you running that program and show the exploit working, and then we'll walk through real quick the differences to build with the RunSafe code protections, and then show how that's different as well. So in this folder here, it's normal. We have our GPS logger, and we've got a library it depends on, and we're just going to run that. We're going to pass in some fake coordinates to this GPS logger, and there's going to be some weird looking data output, and that's the information leak happening. And then the GPS coordinates that came in, and then those get logged to a file. And if we were to run our exploit here, we'll see an address get leaked. So our exploit reads that information leak and then can compute its ROP exploit chain to exploit the system, and then it's going to succeed in creating this file temp hacked. If we look, we can see that there's a file that got created. Obviously, an attacker is not just going to write an empty file to disk, but they would be able to then take control of the system and do whatever they wanted at that privilege level, escalate privileges from there, etc. So, we've got this vulnerable program that's representative of software that might be deployed in the wild, and it's exploitable. Well, how do we fix that? We could go and do a bunch of manual code analysis, hope we find the bug, do a bunch of patching, and continually do that forever and ever for every bug that ever gets found. Or we can deploy RunSafe code and protect against that same thing. And so let's dig into the Docker file on the right here. And we're using Docker here just as a representative build environment. There's nothing that we do that's specific for Docker. You can run it in a virtual machine. You can run it, on a native install on a system. It doesn't really matter. So really, we're going to install the packages in our CentOS 7 VM or Docker container in this environment. And we're going to add a repository. So RunSafe provides our software in an Artifactory instance. So it's really easy to install. You can use apt, yum, APK to do those installs, or even pull down Yocto layer, things like that. Really easy install method. And so we're going to add this new repository and install Alchemist LFR, which is the package name for RunSafe code. And then we're going to do our build again. But this time, instead of running make, we're going to run LFR Helper Make. And so for 95, 99% of the builds that you're going to do, all you have to do is just add LFR Helper to the front of it. We don't care if you're calling make, CMake, Ninja, a build script that somebody wrote 40 years ago. For most cases, you're just going to have to add LFR Helper to that invocation there. And then you'll do the make install the same way. And so now we're going to move over to the LFR protected, and we can see that we've got the same GPS logging application, the same library, but in this case, they're protected. So if we do our echo again, we're going to see an information leak here, and the data looks a little different. That's because the system's ASLR is in place, our RunSafe protections are in place, but functionally we still output that same GPS coordinate, still logged the same way. And so now we're going to run our exploit again. And this time, instead of succeeding and creating this file temp hacked, we'll see that it did not succeed in doing that. And we had a return code of -11. In this case, that -11 means there was a seg fault. The exploit attempted to read or write memory that it wasn't allowed to, or execute memory that it wasn't allowed to, and the exploit failed. And so our exploit script was updated to try and attack this system with RunSafe's code protections, but it didn't actually work. And so that's how you can provide that protection with a simple package install and just adding LFR Helper to any of your build environments. So this works in pretty much every Linux environment, Alpine, Debian, Ubuntu, CentOS, Rocky Linux, Red Hat, etc. And then we've also got some really slick integrations with AOSP for Android, OpenWRT, Yocto, Buildroot, Timesys Factory, and we're soon to have general availability for VxWorks 6.9 as well.